Hello students, welcome back. So let's continue our lectures in sets. So today we are going to talk about subsets. So let's try to understand what exactly is a subset. In the previous lecture, we studied about classification of sets, especially based on the number of elements inside it. Like we studied about empty sets, we studied about finite and infinite sets. Then we also studied about equal sets. Now in this lecture, we'll be studying about subsets. Okay, so consider the set X, where X is a set of all students in your school. So let us consider this to be one of the set, where X is a set of all students in your school, correct? And then you have another set Y, which is set of all students in your class, right? Now let's try to understand what is the relation between these two sets. So pictorially, if I try to represent, suppose this is the school that you are in, right? This is the school that you are in. And then, suppose this represents the set X, right? Now, if you see Y is basically set of all the students in your class. So Y will be somewhat a part of this set X, isn't it? In other words, what we can see is all the elements of Y will definitely be the elements of X, right? And this is what is written here. We note that every element of Y is also an element of X. So if this is the case, we say that Y is a subset of X. Y is a subset of X, right? So if every element of Y is also going to be element of X, then we say that Y is a subset of X. And we express it in symbols in this way. So this is how we say that Y is a subset of X. This symbol basically represents is a subset of, right, or is contained in, right? So this is what this symbol represents. Now, if I go for the official definition, so the definition says that a set A is said to be a subset of a set B if every element of A is also an element of B, right? So the definition says that if A has to be a subset of B, if A has to be a subset of B, then all the elements of A has to be inside the set B, right? In other words, A is a subset of B if whenever A belongs to A, and this A can be, replaced with any element inside the set A. So this here basically is serving as a variable. So this is just a placeholder. So this placeholder can be replaced by any element inside this set A, and for that element is also going to be inside set B. So if A belongs to A, then A also belongs to B. This is when we say that A is a subset of B. So it is often convenient to use the symbol this. So this symbol basically is used and it means implies, right? So if you want to express this definition in terms of mathematical, language or mathematical symbols, this is how you can represent. So A is a subset of B if A belongs to A implies A also belongs to B. And this is what the definition says. And if you want to read it in pure English, it is saying that A is a subset of B if A is an element of A implies that A is also an element of B. Alright? So pictorially, it is very easy for us to understand. If this is a given set, it could be any given set. For example, let us say if this set is A, and if B is going to be a subset of this set, then B has elements which are going to be also the elements of A. So if this is the case, then we say that B is a subset of A, right? B is a subset of A. So this is how we write. All right? Okay. So we may note that For A to be a subset of B, all that is needed is that every element of A is in B, right? It is possible that every element of B may not be in A. And this is what happened with these two sets, isn't it? If you consider these two sets, let's go back to these two sets again. Here, Y actually represented all the students in my class, and X represented all the students in the school, right? So clearly, if we consider Y, all the elements of Y are going to be there in the set X, right? Because all the students of my class are default students of the school also, right? But there could be many more students in the school which are not, which are not the element of this set Y. That means there could be many students other than the students of my class in the school also, right? So here what we are trying to say that for A to be a subset of B, so whenever A is a subset of B, the condition is that all the elements of A has to be there in B, but not the vice versa. That means there could be elements in B which are not basically the elements of A. That means the number of elements in A. So if you want to draw a relation between number of elements of A and B, then number of elements of A will always be less than equal to number of elements of B. It could be less or it could be equal also, right? Okay. Now let's move forward. So it is possible that every element of B may or may not be in A, right? If it so happens that every element of B is also in A. Now there could be a case like here when n of A is equal to n of B. That means all the elements of A are there inside B and all the elements of B also are there inside A, right? So when that happens, then we say that the two sets are going to be equal, and it is pretty obvious, isn't it? Suppose A is a set and there are elements 1, 2 and 3 inside it. Now let's consider two cases when we have a set B which has say 4 elements 1, 2, 3 and 4, and we have another set C where you have say 3 elements 1, 3 and 2, right? Now here if you see, all the elements of set A are there inside set B, right? All the elements of set A are there inside set B. So we will say that A is a subset of B, right? Similarly, we also see that all the elements of C are also there inside set B. So we also say that C is a subset of B, right? But if you compare A and C together, see all the elements of A are there inside set C. So we also say that A is a subset of C, right? A is a subset of C. And all the elements of C are also there inside A. So we also say that C is a subset of A, right? And if these two are simultaneously true, this basically implies that both the sets are equal. Both the sets are equal. Whenever you have A is a subset of C and C is a subset of A, that implies that both the sets are going to be equal, right? I hope you have understood this concept. So the point I am trying to make here is, whenever we have to think about subsets, so there will be always, say, set X, right, is a subset of set Y. The relation will always be written like this, isn't it? Set X is going to be a subset of set Y. The restriction has to always be on the set X. That means the restriction has to be always on the elements of the set which is on the left hand side of this symbol. So this symbol is basically subset or belongs to, subset of, right? This symbol is basically representing subset of. So any set which is on the left hand side of this symbol, the restriction is that all the elements of this set has to be there inside the set on the right hand side, right? So restriction is or the limitation is always on the elements of this set. And you have to see that all the elements of this set should be there inside this set. If that is the case, then we say that this statement is true. And if that is not the case, then the statement becomes false. Right? There is no restriction on the number of elements or the elements of this set. There is no restriction. This set could have more number of elements than set X. This set could have some elements which are not there in set X. That is completely acceptable. But the non-acceptable fact is that no element of set X should be like they do not belong to this set. Right? So every element of this set should be there inside this set. So this is how we define subset. Right? So always keep this in mind. Now, keeping all these considerations, we can conclude two important things here. One is, using these two statements, I can clearly say that a set A, every set A is a subset of itself. That means the conclusion is that every set is a subset of itself. Every set is a subset of itself. Right? So this is the first conclusion. The second conclusion is, since empty set phi has no elements inside it, right? So we can say that phi is also a subset of every set, right? So empty set phi is a subset of every set. So whenever you write any set P, right, two subsets are definitely going to be, here. One is phi and another is P itself. There could be more subsets, but these two will definitely be the subsets of this set P. Right? Okay. Moving forward, let's try to understand with some examples. Now here we have a set Q of rational numbers, and here we have set R of real numbers. Since we know that all the rational numbers are also a part of the set of real numbers, so we can say that Q is a subset of R, right? The second point is, if A is a subset of all the divisors of 56 and B is a subset of all prime divisors of 56. So here you are considering all divisors including prime and composite. So including prime and composite, isn't it? Prime and composite. And here in this set B, you are only talking about prime divisors. You are only talking about prime divisors. So obviously set A has all the prime divisors as well as the composite divisors. And here set B has only the prime divisors. So clearly all the elements of set B are going to be there inside set A. So we say that B is a subset of A, right? Consider these two sets. Let A be 1, 3, 5 and B be the set of all x's such that x is an odd natural number less than 6. So odd natural number less than 6 is 1, 3, 5, right? So these two sets are equal. But again, all the elements of set A are there inside B. So we say that A is a subset of B. All the elements of set B are also there inside A. So we say that B is a subset of A. And if both these statements are true simultaneously, this implies that both the sets are equal, right? Consider the fourth point. So let A is this and B is this. Here you can clearly say that or see that all elements of A are not inside B. And at the same time, all elements of B are also not inside set A. So neither you have A as a subset of B, nor you have B as a subset of A, right? So this is very easy to understand. Now let A and B be two sets. If A is a subset of B and A is not equal to B, then we say that A is a proper subset of B. A is a proper subset of B, and B is called the superset of A. That means the case when you have n of A is less than n of B, right? Number of elements in A is less than number of elements in B, and all A belongs to A implies A belongs to B, right? So for all the elements which are there inside A implies all the elements are also there inside B. So this is a case when you have A is a proper subset of B. This is the case when you have A is a proper subset of B, right? And B will be called the superset of A. B will be called the superset of A, right? So this is something that we should keep in mind. These nomenclatures are something that should be very clear with us, all right? Okay, now consider set A is a proper subset of B, because here if you see, all the elements of A are there inside set B, but there is one element in B which is not a subset of, or which is not an element of A. There is one element 4 in B which is not a member of this set A. So we say that A is a subset of B, and since the number of elements in A is less than the number of elements in B, then we say that A is a proper subset of B and B is the superset of A, right? Here, this is something that we have studied already, that if set A has only one element, we call it as a singleton set, right? Okay, now let's move to some examples. Now here we have some sets given. We have to insert the symbol is a subset of, is not a subset of between each of the following pairs. Since we have already studied that an empty set is always a subset of every set. So here the symbol will be is a subset of. Here A had only 1 and 3. B does not have 3, right? So A cannot be a subset of B. But C has 1 and 3, right? So that means A cannot be a subset of B, but A will definitely be a subset of C, right? Now let's consider B and C. So B had 159, C also have 159. So B is going to be a subset of C, right? Okay. I hope you all have gotten this answer correct. Now let's move to the example 10. We have let A as A, E, I, O, U, that means all the vowels, B as A, B, C, D. Now, is A a subset of B? Clearly no, isn't it? Because here you have A, but also there is an element E inside set A which does not belong to B. So E belongs to A, but E does not belongs to B, right? So clearly A cannot be a subset of B, right? A cannot be a subset of B for sure. So I hope you have understood. Now, is B a subset of A? So here you have an element B inside set B. B belongs to B, but B does not belongs to A. B is not a member of A. So clearly B also is not a subset of. So here A is not a subset of B, and here we can also say that B is not a subset of A. Alright. Next example, let A, B, C be 3 sets. If A belongs to B, B is a subset of C. Is it true that A is a subset of C? Now here you have to be very careful. You have a set A, set B, set C. Here we have been given that A belongs to B. That means A is an element inside B. A is an element inside B. And B is a subset of C, right? B is a subset of C. Now we have to determine whether A is a subset of C or not. So here we will discuss with an example, right? Let us consider this example given here. Let us say we had set A, which is a singleton set and has only one element, that is 1. Now, since this set itself is an element inside B, so consider the set B to be having two elements. One, this set itself. Now, this will be, this will be treated as an element. This will be treated as an element. Although it is a set, but it acts like an element inside this set B, right? And let us consider C to be this set. So here you have, because since B is a subset of C, so we have to make a set C in such a way that both the elements of B are there also inside set C. So these two elements, and let us consider we have one more element 3. Correct? So now these two statements are satisfied. A is an element inside set B and B is a subset of C. Now we have to check whether A is a subset of C or not. Right? Now if you see the set A, so this itself was a set A, isn't it? This rounded term that we are having is A, isn't it? If you see carefully, this A is an element inside C. A is an element inside C. So A is an element inside C, isn't it? When A is an element of C, then A cannot be a subset of C. If A is an element of C, then A cannot be a subset of C. Do you all agree? If A is an element of C, A cannot be a subset of C. Just to give you an example, say for example, if you have a set P given as 1, 2, all right? Now we can clearly say that this 1 is an element of P, but we do not say that 1 is a subset of C, subset of P. Do you all agree? Do you all agree that this 1 is an element inside this set? And if it is an element, it cannot be a subset of the same set. Is it all right? So always keep this in mind. If we have an element inside a set, it cannot be its subset. It will only be acting as an element. It will only be acting as an element, right? Okay. Now let's try to understand what the solution is saying. So here we have considered these three sets. Since A is an element in B and A is given as this set and B is a subset of C, but A is not a subset of C. I hope you all have understood that why A is not an element of, why A is not a subset of C, because A is an element of C. And if it is an element, it cannot be a subset. Is it all right? Here also you have to see that 1 is an element of A. 1 is an element of A. But element inside C, if you go and see that whether 1 is an element inside C, can you see that 1 is an element inside C? No, we do not have 1 as an element inside C. Look carefully. We do not have 1 as an element inside C. Rather, what we have is the set A as an element, right? This 1 is an element of this set, but the whole set is an element of C, right? So clearly 1 is an element of A, but 1 is not an element of C, because if you consider the entire set, this entire set, this is going to be an element of C, not the element inside this set is going to be an element of C. All right. So always keep this in mind. There is always a confusion between a subset and an element. So this is something that we should always be clear of. If anything is an element inside the set, it cannot be a subset unless you have another 1 given here. If suppose we had this C written as if suppose we had this C written as this, where you have this set and 1 and 2 and 3. If C was this set, then in this case, we could have definitely said that the subset formed by this element, the subset formed by this element will give you the set A itself, right? So in this case, we could have easily written that A is a subset of, A is an element of C also, and A is a subset of C also, right? Because this works as an element for C, and the subset having this element, the subset which is formed just by using 1, this itself is also A, isn't it? This itself is also A. Now, in this case, this will act as a subset, right? So, always keep this in mind that when do we use element and when do we use a subset? Because usually we do get a little bit of confusion between subset and element, and we should not be getting confused ever. All right. Now moving forward, let's talk about subsets of set of real numbers. All right. So set of real numbers is like a superset of set of natural numbers, set of integers, and set of rational numbers, even set of irrational numbers, right? So you have, if you try to draw, you have natural numbers, right? You have natural numbers. Natural numbers are basically set of integers. Natural numbers are subset of integers. Integers we usually represent by Z. Integers are subset of rational numbers. Integers are subset of rational numbers. And rational numbers are subset of real numbers. So rational numbers are subset of real numbers. So this is for this entire set, we can say that real numbers, set of real numbers is a superset of natural numbers, superset of integers, superset of rational numbers also. Is it all right? Because we define set of rational numbers as x, where x is equal to p upon q. I hope you all remember this, where p and q are integers, and we make sure that the denominator is never equal to 0, right? So this is how we form set of rational numbers. All right? Okay. Now let's talk about, so this is something that we have already understood. Members of Q include -5, which can be expressed. So all the integers are already there inside set of rational numbers, because this is what we have also written, that all the integers are also there inside set of rational numbers, right? And set of rational numbers are also there inside set of real numbers. All right. Okay. So here you have N as a subset of Z, Z as a subset of Q, Q as a subset of R, right? So this is something. And if you say if a set of irrational numbers is denoted by T, then T is also a subset of real numbers. T is also subset of real numbers, right? All right. Now let's talk about intervals as a subset of R. Now this intervals is going to play a very important role when we solve inequalities, right? When we will be solving inequalities, these intervals are going to play a very important role. So whenever you have, so there are basically two main types of intervals: open interval and closed interval. There are also semi-open and semi-closed intervals. We will see how they are written. So if you have an interval given as, if AB belongs to R and A is a less than B, right? So this is something that we will consider for the entire passage to follow, right? We will consider two real numbers A and B, and A is a smaller real number and B is the larger real number. So if this is the case, And if you have represented a set of real numbers as collection of y's such that y belongs to, or y is smaller than b and greater than a, or we can say that y lies between a and b, where a and b are both excluded. So this is called an open interval. That means you are trying to select all the real numbers which are there between a and b, but you are not considering a and b to be inside the set. So suppose if we draw a real number line, say this is a real number line, this is our number a, this is our number b. So here in this case, we are trying to include all the numbers, we are trying to include all the real numbers excluding this point A and this point B. We are trying to include all the real numbers which are there in between these two. So we represent this as open interval, and this open interval is written as open interval A to B. So this, whenever you have an expression given as this represents set of all real numbers between A and B excluding A and B. Excluding A and B, right? So this is how we define open interval. Now let's talk about closed interval. So in this case, the difference between an open interval and a closed interval is that we also include the end points. That means if you try to draw it on a real number line, suppose this is A and this is B, then closed interval will not only, include all the points in between A and B, but it will also include this point A and this point B. And this interval is written as closed interval A to B. I hope you can now understand thus that this symbol will represent set of all real numbers between A and B, set of all real numbers between A and B, but in this case, including A and B, right? So this is how you represent a closed interval. This is how you represent a closed interval, right? But there could be cases of semi-open and semi-closed intervals, right? For example, in this case, if you have a closed, so this big bracket, if you see, big bracket is a symbol for closed interval. That means if you have written this big bracket, this is an indicative of the fact that you are including this number inside the set, right? Again, big bracket here, that means you are including this number inside the set. And when you have a smaller bracket like this, that means you are excluding this number from the set. Again, smaller bracket represents exclude this number from the set, right? Now let's try to understand what is written here. You have a big bracket here. That means you are including this number. Smaller bracket here, that means you are excluding this number. So you are including this and excluding this. So if you want to represent this on a number line, you have A, you have B, you are including this point and you are excluding this point. That means you are considering all the numbers in between A and B, including A but excluding B. And similarly, if you want to represent this on a number line, you have point A, point B. In this case, you are excluding the point A and including the point B. That means you are collecting all the set of real numbers in between A and B, but you are excluding the point A and including the point B. So this is how we represent intervals. There's one important thing to note here. Whenever you have to include infinity in the set, so infinity is always plus infinity and minus infinity both is always in open interval. That means whenever you have to include minus infinity, this will be always in open interval. Whenever you have to include plus infinity, this will be always in open interval. So infinity is never in closed interval. It will be always in open interval. Just keep this in mind, right? We also try to understand that what exactly is this in terms of inequality. So here we are trying to include all the set of real numbers which are either equal to 0 or greater than 0. That means in terms of inequality, we are considering all the variables which are greater than or equal to 0. So this inequality and this set is basically one and the same thing. Similarly, if you have this, that means you are considering all the real numbers in between minus infinity and 0, and you are not including 0. So if you have to write this in form of an inequality, this will amount to saying that you are searching for real numbers which are less than 0. You are searching for real numbers which are less than 0. So that means on a number line, if you have 0 here, you are searching for a number which is less than 0. That means all these values, and this will go up to where? Up to minus infinity. And this basically says that you are including all the numbers, real numbers, from minus infinity to 0, excluding 0. And minus infinity being infinity itself, it will always be in open bracket, right? So this is how we try to represent all these intervals on a real number line, and we have already understood this, right? Okay. Now there is one point to be noted here, and that point is length of an interval. So what is length of an interval? So whenever you have an interval, right, a comma b, whenever you have interval a comma b or closed a comma b, right? So length of an interval is nothing but the larger value minus the smaller value. So this is nothing but the length of the interval, and it is independent of the interval being open or closed. In fact, this again is also going to be length of a comma b closed or a closed comma b open, right? So irrespective of which of the values you are including or excluding, the length of the interval will always be the larger value minus the smaller value. I hope that is all right with you. Okay, now let's move to universal set. Now let's read what exactly is written here, and then I'll try to explain. Usually in a particular context, we have to deal with elements and subsets of a basic set which is relevant to a particular context, right? For example, while studying the system of numbers, we are interested in the set of natural numbers and its subsets, such as set of prime numbers, right? Set of even numbers and so forth. This basic set is called universal set, and the universal set is usually denoted by U and all its subsets by letter A, B and C. Now the point that is to be explained here is universal set is supposed to be a superset. Universal set is supposed to be a superset. In ideal words, if you try to explain universal set, in ideal words or in ideal scenario, a universal set is something which includes everything inside it, right? But since it is too vague a definition, we try to define universal set in a particular context, right? For example, suppose if we are talking about, your class. In fact, your class suppose you are two, siblings studying in a same school. Suppose you are studying in class 11th and your younger sibling is studying in class 9th, right? Now, if I only have to talk about you two, for this context, I could have easily assumed the universal set to be your school, because your school contains both your class as well as your siblings' class. So in the context of the question, when I am talking about you, your class, and your sibling and his or her class, right? For this context, I could have easily, assumed your school to be the universal set. Whenever we are talking about, say, prime numbers, even numbers, odd numbers, right? Prime numbers, even numbers, odd numbers, and so on, right? So if we are talking about, say, prime numbers, even numbers, and odd numbers, since we know that all of these are basically, a subset of, say, whole numbers, isn't it? All of these are subset of whole numbers. So in this context, I could have easily assumed set of whole numbers to be my universal set. So usually what we do is we define a universal set according to the context that we want to work with, right? Let me give you another example. Let us say if we have a set A containing, say, A, C, and D, right? Another set B containing, say, for E and I, right? Now, if we only have to work with these two sets, I could easily consider my universal set to be to be a set that consists of all the elements that could be inside A and B. So I could have easily assumed my universal set to be a set which has A, C, D, E, and I, right? So for this context, this set serves as my universal set quite perfectly. Or you could also have assumed your universal set to be your set of alphabets, right? Set of alphabets. This could also work, set of alphabets, right? So this is the optimum, number of elements that is required to basically consider a universal set with a context of, working with these two sets. Anything which is bigger than this and includes all these elements will work as a universal set as well, right? So usually we define universal set according to the context in which we are working, right? All right. Now that all these definitions are clear, let's try to solve the questions of exercise 1.3. Before, coming to see the solutions, I would definitely advise you to go and attempt all the questions by yourself. Come back again and try to verify whether you have gotten all the answers correct or not. And if not, you try to understand where exactly you are facing a difficulty, and you'll be able to clarify your doubts by going through the lecture once again. All right? Okay. Let's go for the first question. Make correct statements by filling subset or not a subset in blank spaces. So here clearly we have 2 here, 2 here, 3 here, 3 here, and 4 here, 4 here. So all the elements of this set are there inside this set. So it is going to be a subset. You have A, B, C. Clearly A is not inside this set. So this is not going to be a subset. Here you have X is a student of class 11th of your school, and X is a student of your school. So any student of class 11th of your school is definitely a student of your school. So this is a subset. In fact, you have to understand, this set is basically consisting of all the students who are into your class, right? So all the students who are into your class, and this set basically consists of all the students who are there into your school. So clearly, all the students of your school are, or all the students of your class are definitely going to be elements of all the students of your school. So this is going to be a subset. Then you have X is a circle in a plane, and X is a circle in the same plane with radius 1 unit. So here there is no restriction on the radius. So you can have a circle with radius half, you can have a circle with radius 1, you can have a circle with radius 2, you can have a circle with radius 3. So obviously this set contains circles which may have, radius other than 1 also. So actually this is a smaller set than this, isn't it? This is just a part of what this set could be. So clearly this set is a larger set than this is, so it cannot be its subset for sure. If it could have been written the other way around, that means if suppose this set was said to be A and this set was said to be B, clearly B is not a subset of A, but A is definitely a subset of B, right? So we can write it this way. But in this case, if this is the way the sets are written, obviously B is not going to be a subset of A. Here in the fifth question, you have X as X is a triangle in a plane and X is a rectangle in a plane, right? So clearly this is set of all the triangles, this is set of all the rectangles, and we know that no rectangle is a triangle, so therefore this is not a subset. X is an equilateral triangle in a plane and X is a triangle in the same plane. So clearly here, if you are only considering the triangle, so you have the equilateral triangle also, you have the scalar triangle also, right? You have the right triangle also, and so on. So it basically consists of both the equilateral as well as the scalar triangle, right? But here you only have equilateral triangle given. So clearly all these equilateral triangles are going to be there inside this set. So this is going to be a subset. X is an even natural number, X is an integer. Since we know that natural numbers is a subset of integers, so obviously even natural numbers is also going to be a subset of integers. So this is also going to be true. Okay, now the next question, examine whether the following statements are true or false. Here you have A, B, B. So clearly this is false because all the elements of this set are there inside this set. So this is false statement because this is going to be a subset of this. A and E, X is a vowel in English alphabet. So vowel in English alphabet. So that means this set is A, E, I, O and U, right? So clearly A is there, E is there, right? So clearly this is going to be a subset. So this is a true statement. 1, 2, 3, 1, 3, 5, 2 is not an element of this set. So this is not going to be a subset. So this should not be a subset of this. So this is a false statement because it is given that this is a subset of this. Now here in this set you have only element A. Here in this set you have A, B and C. That means the element inside this set is also there in this set. So this is going to be a subset. So this is true. Now this is a set. If it is a subset of this set, it cannot be an element of the same set. A is an element of this set, but the set containing A is not an element of this set. So this is false. X is an even natural number less than 6 is a subset of X is a natural number which divides 6. Even natural number less than 6, you have 2, 4, 2 and 4, right? Even natural number less than 6, you have 2 and 4. And X is a natural number which divides 36. So you have 1, 2, 3, 4, 6, and then you have 9, then you have 12, then you have 18, and then you have 36. So clearly 2 and 4 are there inside this set. So this subset sign is true. So this is going to be true. All right. Then third is, here you have a set. Now this set you have to see carefully. This is an element, this is an element. This entire thing is an element. Although it is a set, but it is an element. So keep this in mind. This entire thing considered together is an element of this set A. And this itself is a set. That is all right. Right? And then 5 is an element. So we can say that 1 is an element, 2 is an element, 5 is an element. And if we consider this set to be P, then P is an element of A. Right? Now let's try to consider which of the following statements are incorrect and why. So 3, 4 is a subset of A. As I said that this set is an element of A and not a subset of A. So this is false. Correct? 3, 4 is an element of A. This is true. Now let's try to find all the subsets of this set A. For that, we have to understand how to make a subset. Suppose if we consider a set, suppose P is a set given as, for example, say it has element 1 and 2. Now the subsets of P, if we try to write the subsets of P, right? How do we write the subsets of P? One is definitely going to be the empty set. Another is going to be the set P itself, right? Because we have seen that every set is a subset of itself. An empty set is a subset of the given or subset of any set. Now there could be one more set which have only 1 as an element. So this set is going to be a subset of P. You can also have a set which has only 2 as an element, right? So this is also going to be the subset of P. So if you see, if you have 2 elements, the number of subsets is going to be 4, right? Number of subsets, in this case, number of subsets are going to be 4, right? Now consider another set which is given as Q. Say Q is A, B and C, right? So what could be the subsets of this set Q? What could be the subsets of Q? Let's try to find out. Subsets of Q will be definitely phi, then a set having only A as an element, set having only B as an element, set having only C as an element, set having only A and B as an element, right? Set having only A and C as an element, set having only B and C as an element, and the set Q itself, that means having all A, B, C as an element. Now let's try to find out how many number of sets are there. So you have 1, 2, 3, 4, 5, 6, 7 and 8. So in this case, the number of subsets is basically 8. So when number of elements in P was 2, the number of subsets was 4. When the number of elements in Q is 3, the number of subsets is 8. So we can clearly say that number of subsets of set A is always going to be 2 to the power number of elements in the set A. 2 to the power number of elements in the set A. So here we tried to understand that how to make a subset of a given set, right? Now let's see. If you want to make the subset of this set A, before answering any of this question further, let's try to make all the subsets of this set A. So the subsets of this set A will be phi, right? Then you will have a subset which have only 1 as an element, a subset which has only 2 as an element, a subset which has only P as an element. So that means subset which has only P as an element, right? Here this is P in this case. Subset having only 5 as an element, right? Then you will have, so this is when you have considered 1 elements each. Then you can also have 2 elements each. That means subset having 1 and 2 as an element and so on, right? We do not need to go further. I think this is enough for us to understand. So in this case, if you see, is 1 an element of A? Yes, 1 is an element of A. This is true. Is 1 a subset of A? No, 1 is not a subset of A because 1 is an element. Unless you write this as a set, this cannot be considered as a subset of A. But the set itself is not inside A. You have 1 as an element, not 1 as a subset. So this is again false. You have 1, 2 and 5, 1, 2 and 5. A subset you are forming with element 1, 2 and 5. Obviously, this is going to be a subset of A. So this is again true, right? You have 1, 2 and 5 element of A. No, this is a subset of A. So this is not an element of A. So this is false. 1, 2 and 3. See, 3 itself was never an independent element inside this set. 3 itself was never an independent element inside a set. 3 comes as a package, and the package is this whole set. So 3 comes in a package, and the package is in form of a set, and the set has elements 3 and 4. So 3 was never an element of this set. So when 3 was not an element of this set, so you cannot form a set with 1, 2 and 3 as elements and consider it to be a subset of A, because 3 was never alone. Whenever 3 will come, it will always come with this entire package. So whenever 3 will come, it will come as a set having 3 and 4 as an element. So this statement becomes false because 3 was never alone in any case. So you cannot form a subset having only 3. Phi is an element of A. No, this is false because phi is a subset of A, not an element of A. So phi is a subset of A is true, right? And this set, now understand, this is a set, right? This is a set. Phi is a set and phi is a subset of A. Now if you write like this, that means you are considering a set who has an element as a set, as an empty set. Now understand, I'll try to explain it in a better way. You have to be a little careful in this case, right? Suppose we are writing a set as Q, and Q set is written as phi. So now if I ask you how many elements are there inside set Q? So you have one element inside set Q, right? You have one element inside set Q. The element is an empty set. So it's like saying that you have a box, right? You have a box, empty box, and you put another empty box inside it, right? So this box was A, and this B is also an empty box. Now if I ask you whether this box A is empty or not, now consider my statement and consider my question here. We had an empty box and we put a smaller empty box inside it. Now, do I call the bigger box to be empty? No, it is not empty. It has something inside it, and that something is the smaller box. Though the smaller box can be empty, but there is something inside it, right? So that means this set Q, now this set Q is not an empty set. This set Q is not an empty set. This set Q is a set which has empty set as an element. So that means this represents a set which has empty set as its element, right? This is a set which has empty set as an element. Now this cannot be a subset of A because in order for this statement to be true, consider it very carefully. Listen to me very carefully. In order for this statement to be true, this phi should be an element of A. This phi should be an element of A, but phi is never an element of A. The phi is never an element of A. Whenever, see, in this case, suppose for example, if this case, okay, consider this one, right? No, which one? Let's see one. Okay, let's see this example. So when I say this set 1 is a subset of A, then I say that this 1 should be an element inside A, right? If we say that 1, 5 is a subset of A, then 1 should be an element of A, 5 should be an element of A. So all the terms inside this curly bracket should be element of this set. If it is an element of this set, then we can form a subset out of it. Now, if this statement is given, then in this case, the term inside the curly bracket should be an element inside A. But phi is not an element inside A. Can you see phi as an element inside this set? No. So this again is a false statement, right? Write down all the subsets of following sets. I will leave this as an exercise for you. So you have to write a subset of this set. Okay, let's do it here itself. I hope you will be able to verify your answers in this case, right? So let's try to solve this, get the answers. Just a moment, let me select another color. Okay, write down the subsets of following set. So clearly subset of this set is, how many elements are there inside it? 1. So obviously how many subsets are going to be there? 2. 1 is going to be phi and another is going to be the set itself, right? In this case, there are 2 elements, so there are going to be 4 subsets with this rule that we have identified. With this rule we have identified there are going to be 4 subsets. One is going to be phi, one is going to be having only element A, one is going to be having only element B, and one is going to have both element A and B. That means the set itself. So these are the 4 sets. I hope you will be able to write for this, because here you have 3 elements, you will have 8 different subsets made. What will be the subset of this? Nothing. This is going to be a phi, right? That means the number of elements inside this set is 0. So this will have only one subset, and that is going to be phi itself, right? That is going to be phi itself, isn't it? Because the number of elements in this set is 0. So the number of subsets is going to be 2 to the power 0, that is 1. And the subset is going to be phi itself, because we know that phi is a subset of every set, right? So this is going to be your answer. All right, write the following as intervals. I hope you will be able to write all these very easily. You have included 6 here, not included -4 here. So for this one, your answer is going to be -4 open and 6 closed. Here you have both of them as open, so -12 open and -10 also open. Here you have 3 closed and 4 closed, because you are including these 2 points. So you have closed 3 to closed 4. Here you are closing 0 and keeping 7 as open. So you have 0 closed to open 7, right? Write the following as intervals in set builder form. I'll leave this for you to answer, because I can clearly see that if you are able to solve this one, you'll definitely be able to write this in this form, right? Okay. Now the 7th one, what universal sets would you propose for the following? Set of right triangles. So when you are talking of set of right triangles, why not consider set of triangles as a universal set, isn't it? Because this set will definitely contain the right triangles, right? In fact, before writing the universal set, you have to consider both these cases. What universal set would you propose for each of the following? So if you are considering the set of right triangles, here also you can consider set of triangles to be your universal set. Set of isosceles triangle, again you can consider set of triangles to be your universal set, right? Given the sets A, B and C, which of the following may be considered as a universal set for all the 3 sets A, B and C? So in order to consider the universal set, you have to make sure that elements inside A should be there inside it, elements inside B should be there inside it, and elements inside C should also be there inside the set. So you need to have 0, you need to have 1, you need to have 2, you need to have 3, you need to have 4, you need to have 6, and you need to have 8 and you need to have 5 also. So 0, 1, 2, 3, 4, 5, 6 and 8. So even if you do not have 7, it works. But you have to have numbers, all the whole numbers from 0 to 8. If you can have 7, it's good. If you do not have 7, it's again good. But this is not going to be your universal set because you are missing 8 here. 5 is definitely not going to be your universal set because it is an empty set, right? Now here you have all the numbers 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we wanted to have 0, 1, 2, 3, 4, 5, 6 and 8. So this works as a universal set. Again you have 1, 2, 3, 4. You are not having 0. So this will never work as a universal set, right? So I hope you have understood what is subset, how do you find subsets, what is an element, what is difference between an element and a subset, right? And what is a universal set. Universal set is always defined with a context, right? So if you have understood this lecture well, then a major section of the set is already covered. And you will now be able to understand set in a much better way, right? So we will continue this lecture, this chapter in our next lecture. Please do follow the lectures that we are, delivering. I'll be uploading one lecture each day so that you will be able to understand each and every line which is there in NCERT and how do you solve each and every question. Usually what happens is we overlook NCERT too much and we consider the NCERT to be a very basic sort of book. But it is not the case. If you study NCERT well, then definitely you are covering a lot of bases. The first base is obviously JEE mains, and the second base is you're also covering your CUET examination if you are willing to appear for it. So this is going to be very, very crucial for you. So you have to understand NCERT first, and then beyond NCERT is something that we will definitely study when we go for JEE mains and JEE advanced. So do follow these lectures, share it with your friends because it is going to be very helpful. And I'm not pacing anything in terms of completing the lectures very fast. We are learning at our own pace, right? And we are not rushing anything, any concepts. So these are the ideal lectures, as I have said before also, these are the ideal lectures for someone who wants to have a base first, strengthened base first, and then go for JEE mains and JEE advanced examination. So see you in the next lecture. Keep working hard, keep your spirits high, and do follow the lectures very precisely. Share it with your friends, and if you have not subscribed the channel till yet, do subscribe it because we'll be coming with more lectures in the coming days. So thank you.